Works perfect. Alright. So, last stream we fixed some collisions, and this stream it's time to make some fun movement. So, we've got our. Gotta turn down the music a bit. So, we do have our movement here. I think it's time that I disable the shift to speed up that much. Let's just make it like 1.5. This should probably be turned into state in the future. Like this. You go so fast walking down slopes because it's goes down. I wonder if that's something to fix. Because it's just, look at how fast the movement vector is downwards. It's the green one. While upwards it has to, like this is just walking on regular ground, but then also walking downwards. It should really be the hypotenuse now. We'll see. Now I have this, I can walk around. I should be able to b-hop if I'm... I should probably add coyote jumps, to be fair. That's actually the first thing I'm gonna do. So let's save that in the player component. Float last requested jump. And that is, that should be an integer, and this should be, we want this to be milliseconds. So, what is that in C#? If I go into where the jump happens, which I've now forgotten, space, there we go. So I can get a datetime.now. I don't know if that's good enough though. Does silk.net have a silk.net timer? Is there a stopwatch? A new stopwatch instance sets the elapsed time property to 0 and starts measuring elapsed time. Guess this is what we want. So last requested jump is a stopwatch. Let's do that. And this should actually be nullable, because this one should be null here. And in the movement scene then, if we do not grounded, then we do player component, which I'm guessing I have here, and then the last request jump is stopwatch dot start new. There we go. Then we just jump, but here we also check if this is true, or player component dot last requested jump dot elapsed milliseconds. Let's just say 20. Should be able to just do that, right? And that should just fail. And here we will also reset the player component dot last requested jump equals null. Now we should have working coyote jumps. I guess 20 is quite low. There we go, now I have bunny hopping. Oop. It would be fun to have a debug view. I think I do render... I had some sort of I'm GUI... There we go. So let's actually add that to the... Let's move this to the right. Can I not? Yeah, there we go. Put this here. And down here, when I draw new, we can draw the FPS. I don't really care about the FPS at the moment, but now we're drawing a couple of hundred FPS. But what I am interested in is doing an imgui.separator. Actually, we can do imgui.spacing as well. And down here, we just copy this. I do imgui.text, and here we just draw player velocity, which is the magnitude. That's what I want. The player.get velocity component dot velocity dot length. Always love C# for not giving me an error there, even though that shouldn't be possible. Alright, so now I have a 40, which is my movement speed. If I slide, I don't really get up to the same movement speed, whatever. But if I do this, oh look. Oh, I fucked up. There you go, now you can bunny hop. With the source engine movement, which is quite fun. What if I actually do kind of one of my favorite game modes in Counter-Strike is B-hop, so I do wonder if this is more. I mean, there's no like losing of velocity like there is in a game like Counter-Strike here, so you can theoretically B-hop. Like in, oh, I'm trying to look at the velocity while I'm doing it, but because it's kind of hard, just gauge off. But really, you should be able to be up until infinity. There should probably be an upgrade if I ever make this automatic bunny hopping. Because it's quite fun to be hopping around. Alright. One of the main problems right now, I mean, except from the world being this small, I mean, you kind of do want a bigger world when making a game about movement. But I do think that the movement feels a little bit too... I don't know, is it? It's very fast, but I do wonder if it's a little bit too floaty. Or is it the jumps? Excuse me. I do think that, I mean, look. Because like I want the game to feel responsive, not floaty. So well, you can reach a. I think one of the biggest problems right now is the slide being a little bit too. Let's see, 4, 4, and let's make the slide friction. Yeah, that's right. Oh. Because you want the slide to be faster than the. Oh, shit. To be faster than the movement downwards, because I do want the slide to be like a core mechanic. Oh, there you go. I think the slide enter speed is 16 when the player speed is 40. So this needs to be like 50. Let's make this 60. Because really don't want people to be able to be like normally running and then enter a slide. Yeah, there we go. Now you're just crouching. Even though you always slide on slopes, which you shouldn't really do. So here you get up to a speed of 50. So I want to make the exit speed 30. Because you want it to be hard to initiate a slide, but when you're in a slide, you kind of just want to continue right now. Yeah, and then you start crouching. And now you can't slide anymore, so you gotta go up here. You gotta build up. So now, if I start sliding 50, I start build up, and then I go down, and now I can't. So to actually start a slide, I have to go up on the slope, actually start sliding. Or I guess I could do this, no? No, because you don't get it very far. That's fun. And let's also add some double jumps to this, just for fun. Public bool has consumed double jump. False. And grounded or player component dot has consumed double jump, and it hasn't consumed double jump. Then we should jump, and then we do player component dot has equals true. No? If player component has consumed if grounded. If not grounded, then we have. Else, if we jumped on the ground, equals not grounded. And now I should be able to double jump. No. Gonna add this to the debug view. Double jump. Let's make this nice and even, and then I really do need to set up a debug view for all the entities. It would be quite nice. Oh, it doesn't reset when you're on the ground. Right, I thought that would do it. Apparently it didn't. So let's just do that up here. Player component dot has equals true. False. Because this is just saying, are you standing on something? And if you are, then we should, of course. Still though, if ground, if not grounded, then this is true. Let's try to do that. If I do this. No, just remove the double jump functionality. Oh. Right. It did work. It's just that my code did the very funny thing of doing what I tell it to, but in the wrong way. Alright, there we go. Basically, this ran fast enough to where the player was grounded twice. There we go. So now I should be able to initiate a slide into a double jump to get like immense speed. Which is quite fun. I can't enter what is my speed after the jump? Because the jump should hopefully, or like in a good game, it should conserve the velocity, I feel like. But I don't think the slide ever gets up to a speed where, let's do this and let's actually decrease the ground friction. Not the slide friction, that is, but like when you're walking, because I feel like the movement was a little floaty. There we go. Much more responsive. So now if I sit here, and yeah, and I guess I do kind of want the air acceleration. We'll see about the ground acceleration. I'm not entirely sure about keeping it the same way that Source has it, which is that you can do this, but you can't really control the player. Like if I do this and then if I jump, I can't move, but you can do this. I do wonder what the best course of action there is, but let's see here. Go up and then I start sliding. 60. Yeah, that's very far. All right, let's do a timer and see the and let's set up a cube actually in the scene. On the same, but we'll set the X, or actually it's the C axis to like 100 to 100. Just set up a green cube. That's too close. 200, and let's actually not rotate it. Alright, okay. Let's actually remove the fog for now when we're debugging. I'm not actually sure if I should keep the fog, so there we go. Alright, so if I stand here, and if I go into the clock timer and then I just walk there, start, no. Start. We reach it in approximately 6.25 seconds. If I then do this with yeah, 5 seconds. So that's significantly faster. You might want it to be even faster, even on top of that. But I think that's a good start. So you can just do that. I think that was faster yet. Let's see here. I mean, yeah, you can get her in like 4.5 seconds. So it's not half, but it's damn close. Yeah, 3.4 seconds. So it's definitely faster to initiate a slide, but you can't really. The good thing is you can't really, you need to get up in the momentum from the slide. So let's see, you're here, and then you start sliding, and then you're at 60 to initiate the slide, and then you get there. You can't really get that from ground momentum, or of course you can sprint, but I don't know if I'll keep that. Yeah, but you can't really initiate a slide like that. You just start crouching. So, I mean, I'll have to add some visual indicators of the slide enter speed so you know when you can start sliding, but I feel like this is good. Like as a good base. It's quite fun to just run around. Now I'm starting to question whether I would like to add vaulting. Mount vaulting, is it called that? I don't really. I guess how you add vaulting. My idea is, if we just open Penta, is that how the collision currently works is you have the player, then you have like you got the player here. They're trying to vault on this part. So I guess it's actually easier if we show it as a cube. There we go. And then we have this in the background. Let's just fill this in. Do that. So we have the player here. It's trying to mount on this cube. Wait, this should be whatever. So what I do think is you have like a vaulting position. So the player's here. You add like a collision box for the vault. Here, let's say. And then you check if there's if there's an edge. If there's a collision edge on that vertex, that can be. So you check for this, and then you move the player or the player collision box, and you test it in this location. Like if they would have vaulted, and see if you can, if nothing collides there, and if nothing collides there, then you mount. Right? That doesn't seem that hard. So what we need is we need a small box collider. You need to resolve this collision. And you basically need to run create a small you create a small box collider here. That has the same rotation as that, because I don't have line intersections, so this is the easiest. Create a box here, following the rotation and everything of the actual box, but it's basically like 1 pixel wide. You check for the collision on this box, which is the player vaulting collision. If they collide, then you move up there. And I think that should be enough now. I mean, there's a lot of states going on with how to actually animate the player to go from this position up to here. But I feel like that's not really a big issue. I guess the bigger issue is because my collision engine is quite unoptimized at the moment. Or at least it isn't optimized. I don't actually know it's unoptimized yet, because I haven't tested it. But I guess the problem is that you don't really want you don't really want one collision box per edge here to be tested against. Like this. You kind of want to just do a distance check here. Because like, these being width don't really matter. This one being tested for, that's just kind of wasteful. And especially, you should do a normal check so you don't check don't add any collision boxes for these, because you can't vault here. So I guess the first thing to do is to generate all of these edge collision boxes. Then we can go from there. But they shouldn't be part of the collision box component. We'll see. We'll see. So what we want to do, let's actually visualize this in game. Let's start drawing the collision boxes again. There we go. So here you can see all the collision boxes for the game. Which aren't, there aren't that many, but there are some. Oh right, I draw everything in the same, so the collision boxes are part of the shadow. That's funny. Anyways, but should there be a can vault collision box flag? Like, do I have to specify? Do I draw out vault points? It's interesting because I do think that's how games like The Last of Us do it, where they, where like it's a single player game and everything. But since this is a multiplayer game, you do kind of want that to be emergent behavior of the map, not really a design decision. All right. We can actually start with the like set vault points, and then we can go from there. Because then we have stages of. First, we actually get the vaulting to work, then we can automatically generate the vaulting. I think that works fine. All right, so. So let's do the classic thing of adding that to the player component. Public bool. This should, however, be in the direction the player's looking, because as you probably noticed, if you paid attention, the player collision box doesn't move. It's static, because that means that you can go up against the wall, and if I rotate slightly, the player doesn't move. Which is the entire reason. You do actually kind of want capsule collisions for this, because this kind of means that if I walk up against the wall, instead of it being smooth, I just kind of teleport around it. Or same here. I mean, you don't really notice it in gameplay, in most gameplay situations. But yeah, it comes from a time when the collision system didn't have rotatable cube collision boxes. Anyways, so but what I do want is, let's actually do that. We can do it here. Fuck it. Render pass dot draw outline box, and we want to take the var player transform equals player dot get transform component. Player transform dot. Want to do the position of it, and then we need a scale. Let's do 1, 1, 1 for now. See how that works. It shouldn't have any rotation. Should have had a yaw, and let's make it blue. So now there should be just an outline box on the player. Yeah, there we go. So what we want to do now is we want to check the camera yaw, like where the camera's looking on the y-axis, and we want to, so let's do, does it do picture yaw first? Picture yaw. Camera dot yaw, and now it should rotate in correspondence with the camera, but very fast apparently. Telling me the camera yaw is in math f dot. There's a radian, isn't there? Degrees to radians. C#. I swear there's function. Whatever. Math dot pi divided by 180. It's like, this isn't a problem. Like, this isn't a problem for my code. Just have the math straight in there, but it is nicer to just have a radians to degrees function. Oh, it actually isn't degrees. And now I actually want to do a like this, I think. There we go. Now it is strictly facing in the player direction, which it should. Like this, these are the type of problems. If I wanted to vault on this corner, I will be further from the center than if I'm just here because of the just how squares work. Which kind of is a problem, kind of not. I don't really care right now. I don't think you vault on corners. I think people go up like this and vault. So if it ever becomes a problem, then I have to implement capsule collisions. But that isn't today because I'm lazy. But yeah, so what you want to do is you kind of want to do a length dir here and move it in the angle of the camera. Do I have that yet in MMath? I don't think so. No. Because then I'll have a class named SMS package. I should math helper, fuck it. So I need the length there. should give me. Length there, implementation, Game Maker Studio 2. Let's see. It's like one of those functions that I always use, but I can never find the implementations for. Is this the right thing? I don't know. We'll test it out. So in the movement scene here, let's draw a render pass.draw line. And we'll start it at the player transform.position plus and here we actually do want a new public static vector 3 length there takes in a length pitch rad yaw rad, keeping the naming, and then return new length there x length yaw pitch length there y c, and this should only have the pitch. And we want to plus this with math helper dot length there. Let's do 20 in the camera.yaw 0. And this should of course be the color, let's see, cornflower blue. So this should, yeah, of course. This is the yaw we want, because for some reason I made the yaw there in degrees. Hello? Why do you not want to work? Why? This seems to be going in the wrong direction. Is it pitch that I want here? It seems like they are gobbled up. So I think, right? Yeah. They're in the wrong order in this function. Whatever. There we go. So now we have a function that just gives us the where the player's looking. So for this outline box, we will do the position plus this. Will be like 4. And then we will make the, of course I'll clean this up later, but 0. 0, 10, 0. I actually don't know the player side off the top of my head. Yeah, that's way too high. The player is 4.5 in size. Let's say 3.5 is the vault height. Feels like it's moving. Am I wrong? Am I tripping? It shouldn't. All right, there we go. And this length should be like 2. There we go. And then just make this too big around the Y and Z axis. And if I go up here, this should actually also be 2. And actually we should offset the height by 4.4. So now if I walk up to a thing here, yeah, that should vault. Okay, should I be able to vault? This should maybe be 3 actually. Because you can, and vault should take precedence over double jumps. Let's make this 3.5 again. Here we go. So if I do this, now that should vault me. Actually, since I'm in, this should actually be a distance of 1.5. Because you do want it to be inside the player. Yeah, there we go. That should vault. So, what we need now is vault points. So, question. Do I check the collisions for the box here in the world, and then take the entity I collided with, and then that has a vault points component? That's not crazy. That's not crazy at all. I think that's what I will do. So let's go into here. Copy this. Vault points. Gotta do a little bit of this. All right, so how the colliders look is this. I am not sure I want to keep that actually. I think all of the vault points are boxes to simplify everything. Or I just break this out, make it the same. I don't think that matters at all. No. Let's make this into a function. Public static let's do public static list collider collision shape parse collision shapes. Takes in the config and a list collision shapes. Turn bloom. Return collision shapes. Collision shapes. There we go. And this should run component dot collision shapes equals parse collision shapes config collision shapes dot component component dot collision shapes. Yeah. That should be moved up here, and now I can just do this and the same, so we don't really have to care about duplicating code. Collision, no, collider component. There we go. And now, before I forget, let's add that to the if entity.has a volt points component. Now we'll do this for volt points equals entity.get volt point component. Like that. And these are blue. Yeah, I feel like that's obvious enough. Yeah. And now we gotta just make sure this does overrides. Ooh, I don't actually know if it does. We can make it. Let's just make each slope have a volt points component like that. And then in the movement scene in this part, we just do this. And the colliders, and copy in this. There we go. Now this slope should render, if I didn't do anything wrong, of course. Wasn't implemented for expression. Huh. Why? That might be it. No? Does the array assume an item? Am I interpreting that right? Parse array. Yeah, it parses. So we need an early exit. If tokens dot first equals boom. Why? Oh, I should just do this. Early exit. Why do you complain? Tokens early exit. Don't know if that will work. Oh, I did. Alright, so there we have our vault point. So what we want is it to be the same width on the x-axis, 0.1 height, 0.1 width. This could actually just be like this. / if the array is empty, e.g. it starts with an directly after boom, we just exit. 1 second. All right. Got about an hour left until I have to go, so let's make it count. So, what we want, 1 or 0 0.9, 0 0.9, 0 0.9, except on the x-axis. 1 wide, 0 0.1, 0 0.1. Y. Scale 1. Oh, it draws from the top left, does it? No, that's in the middle. Oh, right. This should be 0.45. There we go. Truly the best way to do this, probably, but... Alright, that shouldn't be too hard to collide. So, every frame... Let's check with the active players... in here. Here, actually. If it collides with the players with this box, let's make this smaller. If it collides with this box, we should probably do this, var player look direction offset is this, var height mount height offset. What's this? Player look direction offset mount height offset. There we go. So now what I want to do, actually, let's make this gonna be annoying. Right. There we go. So first and foremost, do I actually put this entire box It isn't crazy that I put this entire box on the player component to make it synced. So let's add that. Public float mount collider yaw vector 3 mount position. There we go. So in the here, recalculate mount collider. And then we do player component dot. Oh, this is a ref, right? I'm not stupid. Yeah. The mount position is this transform. Player component dot mount collider yaw is this, and then we do size. Mount size. That's always the same. There we go. And now let's use this here. Player component dot player component dot mount position. Player component dot mount size. Player component dot mount collider yaw. It isn't perfect, but you won't see this, so it doesn't matter. So now we do have the entire box. So now here I want to check collision resolver dot resolve. New collision shape dot box. Player component dot There we go. So if there is a player in the world, then we want to get the player dot player component equals player component dot mount position, player component dot mount size 0 mount yaw. And we resolve this against the current box. And just change an option, so we do var color equals this. And then we do var collision equals if collision dot is none is some. Then we want to do color equals color dot blue. And then we just pass in the color. So this should theoretically turn this blue, which it didn't. It done do that. Yeah, that just doesn't collide. Because this goes through all the collision shapes in the world, and this tries to resolve this collision. Which for some reason doesn't work. Because this does, I'm not dumb. No. I really should add a debug to show flex specific resolves what it's actually checking. Just checking, but this will just be blue. Yeah. But it does reach this point. Player mount world matrix. I'll draw that. Oh, does this draw relative to the fucking... This is quite strange. So this... What the fuck? Which are the green ones? Green. That should only be the player mount world box. Very, very strange. So this draws the player... transform component and the transform? I don't remember what this does. Why doesn't this just use the player transform deposition? No idea. Well, there we go. Now it should draw the same for everyone. Still doesn't collide though. That's not right. Oh, I do it here. There we go. So why don't they collide? Like they should. Like they should. I get back to doing coding. Hmm. The clue is that the drawing uses while the selected collection checks for a solve on 2 raw collision box shapes and checking the remaining resolve will help. Let's just fix it and then we can get back to coding. There we go. So now we can check for collisions with the surrounding box. I'm guessing this works for these as well. Yeah, as it should. So, what is now our main goal? It is to check in the collided on the collision. I actually have to do this in user space. Okay, let's do. If you press space, when jumping, so we do this. If then we do all of this, right? / jumping. We first want to check for so let's go here. So basically every time I jump, I check all the colliders in the world and then check for if I collide with them. This is going to be problematic later, but I guess it's quite an easy fix to just check a range around, like just don't check colliders outside of 10 radius outside of it. But for now, let's do this. This one doesn't matter. We don't want to draw something because we don't have a render pass when this is being run. Var collided shape. Collided component equals null. We do want to set the entity that would solve to. Collided entity dot equals entity. This isn't used anymore. This isn't used. Don't need this. Now we can just, if collided entity isn't null, we can just return. So I'm going to do if collided entity isn't null, then we do this, else jumping. Console.writeLine attempted mount. Why? Oh, it collides with the player. Can I just do if collided entity equals player, return. And we already have the player in this scenario, so we don't have to do that. Attempted mount on which? I mean, I guess it isn't crazy that this doesn't work. Collided entity player. This will just send out the entity class, most likely. No? Null. So attempted mount. And the collided entity is always null. Who's the lucky gal? ID 0, ID 0. Who could have guessed? It's the flippin' player. Dot. Is there like an ID? Oh. If it's not null, return. Oh, I can't do that here. And then collided, no, it's not collided. If entity dot value equals player, return. That should work. Yeah, there we go. Jump, jump. and here attempted mount. There we go. So, if we attempt a mount, we also have to be colliding with the so here we do var if collided entity is not null, then we want to do var vault points equals collided entity dot get. Oh, let's do is not. Can you do this? No. Get vault points component. There we go, and here we actually want to check if vault points collision isn't equals to null. Entity DAW value. And now we check the collision for each vault point and this, which is basically just this. In vault points. And this entity is of course the collided entity. Dot value. And if it collides, then the vault points collision is equal to collision shape dot dot the box dot position. This won't work. Console.WriteLine checking vault points. Checking vault points box. Position. No, they have to collide, right? So this will never be collided then, I take it? No. I was wondering if my coyote jumps had stopped working, but it seems like they're still working. Is it the same here? Oh wait, is this checking for the wrong collision shape? No. The vault points and player mount box colliding here when they should. Oh. Oh, it is. Well, that's embarrassing. But now it should attempt mount. There we go. Kind of do want to remove checking vault points. Attempted mounts. Transform dot player transform dot position equals vault point collision. Oh. That's because this should be plus collided transform dot. Look at that. I mean, it's wrong. Ah. I do wonder why it's different every time, though. I guess that you're quite good for now. There definitely needs to be an animation though, but it teleports into the air. It seems like it. Does it? If I do this, does it? Slash mount vaulting, and then we do velocity. Surely I have the velocity component somewhere. Is it just val? Oh no, I did. Oh yeah, it's just val. Val dot velocity equals vector 3.0. Because I mean, if you do vault, you don't really want to inherit the position. Yeah, I mean, it's definitely, it's like, it's wrong, right? It is very wrong, but But I don't know what it is. Because, like, it really doesn't... This... Because, like, the box position is this. 0.475. Ooh. No? Like if I add some code here in the movement scene, and if I just do if input dot is key press, let's do key dot arrow left. Transform dot position dot x plus equals 1. Or let's do 475. If I do this, how far is that? Oh, that's not far at all. But it is the entirety of the... Yeah, so what's the difference? Oh. Is it top left? So I have to add... Oh, right. My brain is such mush today. I need to add... So this is from the top left corner. So... But it does seem like this is the center. Oh, this is some spaghetti code that I will have to untangle later. But if I do this... Where does it put me? It puts me in the middle. Right. Yeah. So that's the problem, that the position that I get put in is the middle, but this is relative to the top left corner, because that's where the collisions come from. Plus collided transformed as scale divided by 2. Oh. Right. How do we feel about that? I guess. It also still needs to be relative to the player where they start. It really does just need to be... Yeah, then I want to do plus box dot size dot, really, right? Box dot size divided by 2. That should be enough. Maybe that should be minus. Well, that didn't work, did it? Also, why is this? If I just plus all of these on top of the position, I should come up in that corner. I come up over here. Because that's from the center. So you have to do all of these divided by 2 to get to that corner. But then I want minus on these 2 to get to that corner. And this needs to be remedied because I can't have different coordinate spaces for my... I can't have different coordinate spaces for collider space and world space. It just doesn't work. Yeah, there we go. I guess the last thing I have... Do I have time? Yeah, I do. So, to do fix this shit. All right. So, new player stay time. Vaulting. Actually, where are my collision shapes? There we go. Walking. And then we just do boom, boom, boom. Because for something... I mean, really, I could do the... Like, I could just add more values here. I do like this approach better. Which is basically assigning the values to the states. Look, so... So basically, the difference here is that the previous approach, it sources as integers, which is better for space, obviously. This uses a lot more, but, or not a lot, but whatever. And, but then I can assign values to those integers. So for example, for the vault position, I do want where the vault is supposed to go and where it started so I can lerp between them. During where it is. This approach basically allows me to add a vector 3 vault position. And now I have a value assigned to the vaulting state. So if ever I read from the vaulting state or the player state, then I can just take this, boom, and use it. So, so yeah. So what I do now is I go through all of these and I do new sliding. Now, this should work in theory, but of course I don't know that until I actually test it. That seems to work just fine. So here, I want to do a player component dot state equals player state dot vaulting with the, and this should use this value, and it should also set the player state 0 like this. I really do need a better state machine for this, but whatever. So I do need a state machine, but while I don't have a state machine, let's just do if client, if player, actually let's take out the player component first. If player component dot state is player state dot vaulting, then we do this, or we take all of this into a big if statement. Wow, woe is me. And if it's vaulting, then I do kind of want to lerp between the positions. So actually this needs a vector3 start from position, and that should actually be to position. All right. So if we are in the vaulting state, then you just really want to lerp between the two. So let's set a time equals 100. Do I want a stopwatch here as well? Might as well. Wherever I set that now. There we go. Stopwatch dot start new. And then we do, let's do 100, or let's do 500 milliseconds to vault. MS. So we do, I actually want to get the transformer as well. Transform.position equals math. Let's get a math helper for vector 3 layer. Do that here. Math helper dot lerp. We want to lerp from vaulting dot from position to vaulting dot to position, and t is time ms divided by, or actually we want to do vaulting dot stopwatch dot elapsed milliseconds divided by time milliseconds. And then we want to do if dot is greater than 5, is greater than time ms. Player component dot state equals player state dot walking. And do the same for velocity, and to just val dot velocity equals vector 3.0. Actually, kind of do want some momentum from the lerp, but I think this is good enough for now. Let's turn off the shadow previews for a second. A little bit too slow, in my opinion. I mean, it's supposed to be the fastest movement option in the world, but to get over walls. Yeah. Let's actually also change this quickly. For this to be divided by 2. Kind of want to be a little bit inwards. I think that's good enough. It's very, very jerky, but I mean, if I make this really slow, make this 3 seconds. Yeah. Because what it does, is it has the player starts here, and and this is the queue it's going to go up on, and it does this to try to get to the position. So when the player is here, it resolves to this position, and then suddenly it can like resolve upwards and it goes here. But the problem there, of course, is that we don't want that. We want the player to really go in this type of motion. I mean, you could do that it goes X then, or Y then X and C. Let's try that actually first. So if we go into the code here, if for half of it, if this is a less than time ms divided by 2, else we do this. So then we want to lerp from vaulting from position to vaulting dot from position dot x, y vaulting dot from position dot c, and then we just go to position. Let's see if this works better. No. Then it lerps from this position. Let's see. It still jerks. Ah, it's better. Oh no, this should just be. That's definitely better. I mean, it isn't the best, but if I just make this to 500 milliseconds, then I can't imagine that this doesn't look too bad. Nah, need some. If we could just add some smoothing to this, then that would be fine. But that's good enough for now. If you need to map vault. So if you go up here, and they can go over the wall. I mean, animations are definitely missing, right? That isn't too bad. And if I stop this entire query, then I can just go up, slide down, stop drawing the movement vectors as well, of course. So you just see what the game should be seeing. I don't know why that vector's drawing. Why do we have... Oh, it's this one. Well, let's not care about this. Just remove it. There we go. So here's the actual game. If we go up, and then slide down. Start there, slide, and then... I kind of want that to be higher because of that interaction. How and where is this calculated? I forgot 5 seconds ago. There we go. Right? Yeah. No? Oh, I set that in the player directly. Let's see. And for my last trick, I will test if this actually works as it should. Slide. Now you can go up. Alright. Well, that's... Well, that's, I think, good enough for today. I feel like I've made a lot of movement strides. Added some... the sliding, the vaulting. I think creating a simple world would be good for around, like, tomorrow. Yeah. I feel satisfied. Been a good stream to get this up and running. So let's commit this. Let's see what has been changed. Vault points. Added that box. What's this? It's just formatting. Fix the configs. Added this resolve. And then a lot of movement scene changes. So add vault, add simple vaulting. In general, yes, let's sync that. There we go. Let's check what has been done up until now. It's been mostly sliding today. So I'm guessing tomorrow, yeah, will be it will be whatchamacallit, when we actually make something to move around. And I guess wall running would be a nice thing to have. Like if you have a fast-paced movement shooter, wall running, wall jumping. We'll see what I come up with. I think the world comes first, because when you have a world like that looks like what you want, then you can very much more quickly iterate on it. So yeah, let's call it here for today. Let's see, the stream was a stable 2 hours, not too bad. Yeah, see ya.